Hello friends, today we are going to learn about uh, pairwise alignment, global and local. In this, we are going to learn how to install first Biopython. After that, how to do pairwise alignment from using how to import different substitution matrices, how to align the sequences, and how to visualize or print the alignment files that we are going to learn today. So basically, pip install biopython. This is we know that this command can execute this pip install biopython will install biopython, and after that we will see that from bio import pairwise 2. So what is pairwise 2? Pairwise 2 is nothing but pairwise sequence alignment program that is present in bio module. After that, we are using from bio.align import substitution matrices as a mat list. So basically, substitution matrices is nothing but a matrix that is used for aligning two different biological sequences altogether. So the matrix info class has been moved to bioalign substitution matrices. Here, what is happening? That matrix info class has been moved to bioalign substitution matrices. From bioalign substitution matrices are matrix info is moved to bioalign substitution matrices. Okay, so after that we will import two random sequences like atgc agtc gt. This is a first sequence. Sequence number 2 is nothing but atcgg tcgt. Okay, after that, we are loading the substitution matrix, that is Blossom 62. Blossom 62 is not, and Blossom 32 are two substitution matrices that are used basically, but Blossom 62 has a more advantage for doing the pairwise sequence alignment. So here, what we are going to learn from loading the substitution matrix. So how to load the substitution matrix? To load the substitution matrix, we will first define matrix is equals to mat list. So here what is happening, substitution matrix from bioalign is getting imported as a mat list. Dot load, it will load. Dot load, it will load Blossom 62. After that, performing local alignment using pairwise 2. So after that, we are going to perform the local because after using this matrix matlist dot load Blossom 62, Blossom 62 will get loaded in matrix in this matrix program. After that, to perform a local alignment, we'll use alignments equals to pairwise dot to align dot local the DNA sequence 1 sequence 2 matrix, and its valuable characters are nothing but -10 to minus 0.5. So these are the basically to know the score. These are the basically scores, and basically these are fixed, so we don't interfere with the scores. So after, to print the basic alignment that we have done, we'll use formula print for alignment in alignments. So to get this alignment from this alignments file, we'll print pairwise dot format dot star alignment. So we'll run this program to visualize what is the output. So I'm running the program. So basically, it will take 1 or 2 seconds to totally run the program. It is connecting to it is allocating the time connecting to Python 3. So basically, it will take some time to connect to BioPython, and it is executing. So within 2 to 3 seconds, it will execute the total program, and will give us required solution. So it is executed. So we are going to know about our result. So our result is here. So first BioPython got loaded as a BioPython 1.88. and after that we successfully installed the package biopython, successfully installed biopython 1.88, and after that we did the scoring. uh, we uh, we got here the alignment which is 40, and it is a basically local alignment. So local alignment gives score of 40, and the characters which are matching got shown here. So what if we want to go for global alignment? So we'll first write here, and we'll paste here the same program, and we will choose here global DS, global DS. So it is global alignment. Okay. So we are running it run now basically, and it runs successfully within 4 seconds. So here 4 seconds is nothing but its time to get the result, and after that we are going to know. So this is the complete sequence: ATGC, is AGT, CGT, and AT dash CGG, TCGT. So these are nothing but global alignment. So this is for a known sequence which is short. So here what we can see, AA is got aligned, TT got aligned, and GCR, G is not able to align with C, but their gap is present. So here gap penalty will come, and the before was score was 40, and now score is 39. And after that CC got aligned in a sequence. After that AG not aligned, GG aligned, and TCGT, these are aligned together. So this is how the local and global alignment we can run on the basis of BioPython. So after that we'll import some files. So we are going to import some data. So these are the RIN FASTA file, 1, 2, 3, 4. So these are the four sequences basically: 1, 2, 3, and 4. We are running them, we are opening them in our FASTA, and what we are going to do right now then, we installed them, we successfully imported them in this Google Colab. After that we are going to know that will these sequences run by using our scoring matrix. So here what I will do, first I will run the local alignment of sequence 1 and sequence 2. Sequence 1 is nothing but we'll copy its path. First I will copy the path of RIN, and I will paste here. We have to first import, we have to first get sequence IO from bio, import sec IO. Okay. After that we are going to know that will it import sequence 1, sec IO dot read. After that in double inverted comma. We will paste the path, and after that we are going to know about what is the sequence format. That is the first about the sequence format. So here what I did, seek IO read FASTA format. After that, we are going to import the second FASTA file. Uh, 1 minute, 1 and 2. So basically, I will open only these two files. I will copy its path. Okay, and I will give it here. Seek IO dot read Control V. This is the FASTA format. After that, I will give comma, and in the double inverted comma, I will specify the format name FASTA. So here, what I did basically, first of all, from bio, I imported module sec input output. Okay, so this sequence input output I imported, and this sequence input output, what will it will do? It will read this FASTA file in this collab, and as a sequence 1. After that, this sequence IO will read the sequence rin2 dot fasta as a sequence 2, and it will do the complete alignment, that is local alignment. So we are going to run this local alignment first. So here some problem was there. Alignments, pairwise alignment, reading the content. 1 minute. I will again specify sec IO dot read FASTA, comma, FASTA is nothing but its sequence format, and I will close the bracket. After that, I'm going to again copy this, copy, Control V. Here S should be capital. Here again S should be capital. I will run it. So here say pairwise align local. I will give here global, and I will run global DNA sequence. So here matrix is nothing but matrix blossom alignment. Alignment was nothing but it's okay. So what is the problem? I will first decode it. Okay, string sequence 1 and string sequence 2, this we have to define. Actually our two sequences are nothing but strings. So what I will do here, I will define the sequences. Control V. Okay, so here what I did, I defined sequence as a string sequence dot sec and string sequence 2 dot sec. These are the sequences, because we are importing here directly sequence dot sec as a sequence. Okay, so I will run it. So here global sequence was successfully run, and it's and I will visualize the sequence, so how it will look like. So here is nothing but this sequence. This sequence score was, so from TTT it is started, and its score was 28,976, and this is the entire alignment of the sequence. So we can run, we can know this is the total sequence. So again I will copy the all program here. I will go to code. I will paste the all program. To perform local alignment, and what will be its what will be its other means what score I will get. I have a question. So I'm running here local alignment. Okay, so here I am typing local, and I will run it here. Here I'm again I will cancel it, I will interrupt it. Okay, and I will give it here name 2. Okay, sequence dot fasta 2. Okay, and I will run it again. Actually, rin.fasta is first file, and rin2.fasta was second file. So I executed these two files to align them completely. So execution will take some time, because it is running the all program, and this execution I think it will take near about 1 minute. So up to that we'll come to know that after basically changing this local to global, we'll get global alignment, and to change it from global to local, we'll get local alignment. Okay, so it is still running the execution. See, this icon is showing the execution is still running, so it will take some time to execute totally. Meanwhile, I will again explain you. Pip install biopython is nothing but a command to install biopython. From bio we are importing pairwise 2. Pairwise 2 is nothing but pairwise 2 sequence alignment program. After that we imported from bio import sequence input output, that is seq io, and from bio.align we imported substitution matrices as a matrix list. matrices, defining sequence random sequences. So here sequence 1 is equals to seq io dot read content in fasta dot fasta. So here this is the file path of the fasta file, and it is the format of the fasta file. Sequence 2 is nothing but seq io dot read content into fasta. Loading the matrix is equals to mat list. That is mat list is nothing but substitution matrix imported as a mat list. This substitution matrix from the bioalign imported as a mat list, and this mat list will load blossom 62 as a matrix. And here we will get alignment, perform alignment. Alignments is equals to pairwise to align local DNA sequence string 1 sequence sequence 1 dot seq string in the under bracket sequence 2 dot seq bracket close comma matrix is nothing but this mat list that loaded blossom 62, and minus 10 and minus 5 are nothing but matrices scoring. And after that, so here we got the result. This is 27,580. So we are going to see the result first. So here, 1 minute. Execution is still going on at some point, because total execution will take some time. So this is the this is the sequence TTT again, and its score is nothing but 27,580. Okay, so we successfully run our sequence alignment, and it is still running, because sequence is nothing but we're at 28,500 something base pair long, and it will run end to end. So therefore, it will take some execution time. Global alignment executes on the basis of first to second and all sequence. It will run from first to last sequence, and the local alignment will run on the basis of its clusters. That will so that will it will show the clusters and directly scoring matrices. So here what we did, we successfully executed the above program, and this is nothing but score and all these things. So today what we learn that local and global alignments are the two types of alignments, and we can run them by using Biopython. Okay, so thanks a lot, friends, for knowing. And meanwhile, uh, I will after some days I will upload my day 3, day 4. The today was the day 3, and on day 4 I will load. So this sequence alignment was completely run. So this is it will take near about 5 minutes to run, and from tomorrow onwards we will learn we'll learn multiple sequence alignments. Okay, so learn it. So again I will explain you sequence install biopython. To install biopython, to import different command modules in biopython, bio and bioalign, Sequence 1 and sequence 2 are imported readed files of in FASTA. You can change your you can give any content that you want to and specify here the format of the sequence. Matrix is loading. We are loading matrix matlist dot load blossom 62. This is the blossom 62 matrix that will score and load the score alignments pairwise to align local alignment string 1 sequence, string 2 sequence matrix and its scoring matrix, its score. For alignment in alignments, print alignment. But how pairwise to format alignment dot alignment. Okay. So here what we did, we imported it. So thanks a lot, and thank you for watching my channel. And in main description, I will give you the commands. Okay. Okay. Thanks a lot.